This next section is called functions. It's part of paper 1, but there are other functions that we do in paper 2, like trig functions. I want us to look at functions that we do in paper 1. There are about 5 in all, but at times we might add the 6th one, which is also not a function, but we can change it into a function. For example, a circle. Let's look at the 5 main functions in Kulumangao. The first one is called linear graph. It's a linear graph. Other people call it straight line graph. As the word explains, it's just a straight line graph. For example, if I've got a Cartesian plane, this particular graph that I'm sketching on this Cartesian plane, these are the x-axis and these are the y-axis. So this is a typical straight line graph. But like all other graphs, straight line graphs have got what we call a general formula. This is a general formula for a straight line graph. It's y is equals to mx plus c. That's the graph that I want us to start with. But I want us to have an overview of all the graphs first. Let us look at all the graphs. I said there are 5 in all. The first one is straight line graph. The second one that we'll be dealing with is a graph called the parabola, or the quadratic function. The third one is a graph called the hyperbola, hyperbolic graph. The fourth one is a graph called the exponential graph. That's exponential graph. The fifth one is called a log graph, a logarithm graph. These are the 5 graphs that we'll be looking at in this section. I usually add the 6th one. I say 5 plus 1, which is a circle. Though a circle in its own is not a function, but it can be restricted such that it becomes a function. Let's have an idea of this one. This one has got a general formula. Like all these graphs have got what we call a general form. The general formula for a straight line graph is y is equals to mx plus c. The general formula for a parabola is y is equals to ax squared plus bx plus c. It is ax squared plus bx plus c. This is the general formula for a quadratic graph or a parabola. The hyperbola will have also a general formula, which is y is equals to a over x minus p plus q. Others, they use k there instead of a. The exponential graph, it is an exponential graph. The equation is y is equals to a times b to the power x minus p plus q. This is generally what an exponential graph general equation will look like. The logarithm graph, the log graph, is usually y is equals to a log x to base b. This is what a log graph will look like. So it is important that you should identify with these general equations. Then the circle, usually the equation of a circle is y squared plus x squared is equals to r squared, the one that we know from the theorem of Pythagoras. Y squared plus x squared is equal to r squared. Right, let's look at all these functions, these general equations. It is important that you should take note of it. The first one is y is equals to mx plus c. The second one is y is equal to something. The third one is y is equal to something as well. The fourth one, the fifth one. But the sixth one is different. So it is important that you should know how to put this one like in all other graphs. Remember, y is the graph. When you talk of the graph, we are talking of the y. So how can we make y the subject here? This then will be y is equals to, you take this x squared this side, I will have r squared minus x squared. Remember that since I'm putting a square root to this side, it should be plus or minus square root of that. Okay, remember, as it is now, it is not a function, but it can be restricted such that it becomes a function. Let's have a general overview of these graphs. Remember, you must have an idea of how a straight line looks like. This is a typical straight line graph. Remember, it's a Cartesian plane. These are the x-axis, these are the y-axis, this is the origin. That is a straight line graph. We'll talk more about the straight line graph this next slide. A general overview of a parabola is a graph that will look like this one. This is how a parabola will look like. That's how a parabola will look like. Look at the next one, the hyperbola. It is a graph. You must have a general understanding of it. It is a graph like this one. It can be in different quadrants. We'll take each and every one after this general overview. Let's look at the hyperbola, the exponential graph, I mean. The exponential graph will be a graph that looks like this. It will go up exponentially. That is an exponential graph. The log graph, it's a graph that will cut the x-axis. This is a typical example of a log graph. Remember, it is the inverse of the exponential graph. The circle graph, this is generally what a circle graph will look like. It's just a circle. Right. Just before we deal with the functions, I just want us to understand one thing and one thing only. You've got to understand what a function is. Before we even talk about the linear graph, I want us to think of what a function is and understand the definition. A function is a one-to-one relationship, and when we use a vertical line test, it will cut that graph at only one point. For example, if Sipho has a relationship with Thandi and another girl, let's call her Cindy, has a relationship with Sipho and Newo. Let's look at these two types of relationships. Look at the first one. This is a relationship between Sipho and Thandi. However, in the second part of relationship, Cindy is involved with both Sipho and Newo. Which relationship do you think will be functional between the relationship of Sipho and Thandi and the relationship of Cindy and Sipho and Newo at the same time? You can see that this relationship will be more functional than this one, because this Cindy will be involved with two people at the same time, which is not a good thing to do. But this one it's functional. This one will work. So a function is a one-to-one relationship. And when we test it by using a vertical line test. For example, when you've got a straight line graph, let's use of a straight line graph. When I use a vertical line test, it cuts this graph at only one point. Hence, this will be a function. In other words, we use a vertical line test to test whether that graph is a function or not. Let's look at the parabola. The second graph we talk about is the parabola. Now, let's use a vertical line test. If I use my vertical line test, it should touch the graph at only one point. Yes, remember, this is the graph. It only touches it at one point. Therefore, this is a function. Let's look at the last one, because all the other ones will be a function because it will cut it at only one point. But when we look at the circle, look at the circle. Let's use a vertical line test. It cuts there and cuts here. So a circle as it is not a function. But we'll deal with it when we go to it. Why am I including it as part of the functions? Right. Let's go back to the first one. It is important that we must know more about our linear graphs because it covers a number of sections in our mathematics. Remember we said the equation is y is equals to mx plus c. This is the general equation. But it's also important to note that there is another equation of a straight line graph. In this particular case, it will be y minus y1 is equals to m into x minus x2. We usually use this one mostly in paper 2 when we're dealing with analytical geometry, but it doesn't stop you using it here. Remember, you only use this formula when you're given the gradient and any other point. All right, sketching this graph. When you sketch a straight line graph, you just need 2 points. What are those points? Look at this one. This is the graph. For me to sketch a straight line graph, I will need to have maybe this point and that point. Then join them together. This is what we call a straight line graph. What is the name of this point then? This point is called the Y-intercept. What is the, remember these are the y-axis and these are the x-axis. So to intercept means to cut. So this is the y-cut, this is the x-cut, the x-intercept. This point is called the x-intercept. It is the point where the graph cuts the x-axis. This is the point where the graph cuts the y-axis. Let's remember this thing. What is it that we put here? These are all the x values that we put here. What is it that we put this side? We put all the y values. So what is it that we don't write here? Are x's. We don't write x on this line. We only write y's. So on this line, the value of x is equal to 0. And here, the value of y will be equal to 0. So it is important that we should understand that whenever we are looking for the y-intercept, the point where the graph cuts the y-axis, you must always make the value of x to be equal to 0. In the same way, when you are looking for the value of x, then you must always make sure that you make y be equal to 0. In that way, you'll be looking for the x-intercept. One more time, when looking for the x-intercept, y must be 0. When looking for the y-intercept, x must be 0 because we don't have x on this line. Right. This is the equation of a straight line. Remember, it is important to note that in this section, you might be asked to find the equation. In all these graphs here, we might be required to find the equation. And it is vitally important that we should exactly know what is it that we are looking for when we have to find the equation. Number one, in this graph, whenever we're looking for the equation, we're looking for m and c. What is m? M is the gradient. And what is c? C is the y-intercept. So in this case here, if this is point A and this is point B, we know that point B will be the y-intercept, but point A will be the x-intercept. Let's remember this thing one more. When we are looking for the equation, we are looking for two things in the straight line graph. We're just looking for the gradient and the y-intercept. However, when we sketch the graph, when we're supposed to sketch the graph, we also have to look for two things, which is the y-intercept and the x-intercept. In that way, we can be able to sketch the graph. Right. Another thing to take note of going forward with these other graphs. To sketch this graph, you need 2 points. Look at number patterns there. To sketch this next graph, you need 3 points. To sketch this next graph, we need 4 points. You can see the number patterns going up there. To sketch this one, we need 2 points, the x-intercept and the y-intercept. To sketch the parabola, we'll need 3 points. The y-intercept, the x-intercepts or the roots, as well as the turning point. To sketch the hyperbola, you will need 4 points. What? The x-intercept, the y-intercept, the x-asymptote, and the y-asymptote. So it goes like that. You need 2, you need 3 points, you need 4 points in that way. We'll tackle the other ones as we move on. Right, that is the straight line graph. So what is it that we need? Let's just take a typical example of a straight line graph before we look at how they set them in the exams. For example, if I give you the graph y is equals to, maybe just before I give you the examples, it is important that we should know more about the gradient. Remember the gradient, the formula is m is equals to the change in y over change in x, which is equals to, if you are given 2 points, you can call it y2 minus y1 over x2 minus x1. It is vitally important that when we talk of the gradient, we should just see the gradient before we even calculate it, whether it is positive or negative. If the line is like this, you must know how is the gradient. If the line is like that, you must know how the gradient. If this is line 1 and this is line 2, you must know that for line 1, the gradient here will be positive. For line 2, the gradient will be negative. Suppose we forget, this usually helps me to remember which one is positive, which one is negative. Look at this axis this side and look at this axis. How are these axes that side? They are positive. All the axes this side are positive. How are the axes this side? They are negative. Therefore, if I come in from this side and sketching the graph, where did I start from? From the positive side. Hence, this line will have a positive gradient, This will have a positive gradient. 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 So you must be able to see it before you even calculate the gradient, that it will be positive. Because remember, what is it that you are looking for here? The gradient and the y-intercept. I'm talking about the gradient for now. Look here. This side is negative. So if I'm coming from this side and sketching the graph, so the gradient of this one will be negative, no matter where I take it from. How is the gradient of this line? It is negative. How is the gradient of that line? It is negative. How is the gradient of this line? It is negative. So it is important that we should see the gradient before we calculate it, so that it will give us the idea of our solution. Right, it is also important to note that if we've got lines like this, these gradients are parallel. Therefore, the gradients are this. These lines are parallel, therefore the gradients will be the same. If this line is like that one, the other one is like that, and this is 90 degrees, we call this perpendicular lines. So you should know that the gradient of the first one, C multiplying the gradient ESB, will give us -1. So the product of their gradients will be equals to -1. Whereas this side, for parallel lines, these two gradients are the same. For perpendicular lines, the product of these gradients are equals to -1. So it is important that we should understand it in that way. Now, let's move on to the Y-intercept, the C. Y-intercept, we use the symbol C. Whenever we are looking for the Y-intercept, remember one thing and one thing only. You just have to make your X equal to 0. Then you'll be able to find it in that way. X-intercept, you make Y equals to 0. Y-intercept, you make X equals to 0. Let's take one example or two. Remember, you might be required to sketch the graph or respond on the questions on the graph. Let's take one each. Suppose we need to sketch the graph of Y is equals to maybe X plus 2. Just that one. Remember, there are three ways of sketching the graph. The first one is called the table method. The second method of sketching the graph is called the dual intercept method. And the third method of sketching the linear graph is called the gradient intercept method. It's the gradient intercept method. Right, these are the three ways in which you can sketch these graphs. The first one is called the table method. The second one is called the dual intercept method. The third one is the gradient intercept method. What is the table method? It is the method that uses the table. Remember, in your lower grades, you used to have a table like this, where you'll have X there and Y there. Maybe you just give your values of X as -1, 0, and 1. Then you're required to find the corresponding Y values. In that way, you'll be able to plot those values until you get a straight line. We usually do this in lower grades. Look at the second one. The second one is called the dual intercept method. The third one is called the gradient intercept method. Intercept method, right. Let's look at the second one, the dual intercept method. This method, dual means 2, this means 2. In other words, we use the two intercepts. What are these two intercepts? It is the X-intercept and the Y-intercept. This is the one that is used mostly, where you just need to find the X-intercept and the Y-intercept, then you sketch the graph. Let's use this method to sketch this graph. Remember what we need. We need two things, only the X-intercept and the Y-intercept. How do you find the X-intercept? Whenever you're looking for the X-intercept, we make Y equals to 0. Let's find it here. Let's find the X-intercept. X cut. We let Y equal to 0. That is what we do when we're looking for the X-intercept. We make Y equal to 0. Remember, we've got Y is equals to X plus 2. Let's work it out. So wherever there is Y, you put 0. Let's do it. So this would be 0 is equals to X plus 2. Remember, we're looking for X. So 2 have got to come this side. No X, only no minus 2. So that is the value of the X-intercept. Let us now find the Y-intercept. We do have the X-intercept. Remember, we only need 2 points to sketch the straight line graph. We need the Y-intercept and the X-intercept. Let's quickly find the Y-intercept now. Remember, in the Y-intercept, Y-intercept, Y cut. Siyasenza about 0, siyasenza X. So X here becomes 0. Let's work it out. The same graph, where there is X, we're going to push in 0. So we'll have Y is equals to nangu X, lakona kono X, sasifaka 0 plus 2. What is 0 plus 2? So Y in this case would be equals to 2. So this is the value of Y. Right. Remember, we said we needed 2 points, the X-intercept as well as the Y-intercept. Once you've got these 2 points, we can easily sketch the graph. Look at the x's. X's are negative, so I'll need more negative part, and y is positive. So I plan the graph. X is negative and y is positive. So I can put my graph in this form. I know that my graph will be mostly on the second quadrant. Look at this one. X is negative, y is positive. I need more time gaga positive. So if this is 1, that will be 2. Y is positive 2. And x is negative 2. 1, 2. Negative 1. This is the main point, and this is the main point. Then we sketch this graph. Remember to name your graph. This is the graph of y is equals to x plus 2. Cut.